Great, thank you. Well, welcome back. I hope folks enjoyed a quick impromptu break, and we're really delighted to get started again with the first of our 4 anchor panels. This one is on the future of aviation. How will next generation aviation technology reduce environmental impact and transform the industry? Aviation is critical to our connected world, but comes with a heavy carbon footprint that contributes significantly to climate change. Innovations such as drones, electric-powered planes, and hydrogen-powered airliners are instrumental in advancing sustainability while also offering many challenges and opportunities. As you all might know, Citrus represents 4 of the UC campuses. So we're headquartered at UC Berkeley and have close partnerships with the campuses at UC Davis, Merced, and Santa Cruz. So you'll see that reflected in each of the 4 anchor panels that you'll see the rest of the day. This morning's aviation panel was organized and convened by Michael Matkin, who's the executive director of Citrus at UC Santa Cruz, and Ricardo Sanfelice, who will actually join the panel here in just a few minutes. He's the director of Citrus Aviation and also a professor at UC Santa Cruz. UC Santa Cruz, as you'll learn, is home to the SIDER drone pilot training program. And the Baskin School of Engineering at Santa Cruz represents a combination of world-class, high-impact research on a campus known for social responsibility and diversity. So it's a great match for Citrus and all of our research interests and goals for social impact. The panel this morning will be moderated by Dr. Becca Fenwick, who directs the Citrus Initiative for Drone Education and Research, or SIDER, as I mentioned earlier, at UC Santa Cruz. And she will make some introductory remarks and introduce the rest of our distinguished panel. Over to you, Becca.
Thanks, Camille. So welcome, everybody. Very excited to be here this morning to talk about the future of aviation. The program that I run at UC Santa Cruz, the Citrus Initiative for Drone Education and Research, SIDER is much easier to say, focuses on educating the next generation of aviation workforce and primarily focusing on how to diversify that. And so we train undergrads how to fly, we help them get their Part 107 drone pilot's license, and then we offer them the opportunity to be employed by us when we take external contracts and fly drone programs for collecting data and processing it for different clients, both internally for researchers and external clients as well. We liaise with industry and work with them on internship programs and bringing students into the workforce as well, and also answering and addressing research questions that those industry partners may have. We're also working quite extensively in the region on workforce development and liaising with other institutions of higher education nonprofits, such as Hartnell Community College, the Digital Nest Group down out of Salinas and Watsonville, and then working really closely with economic development as well. So the Monterey, the drone automation and Monterey Bay DART, so drone automation, robotics and technology, and other groups MBEP in the region as well. So sort of pulling all of those pieces together to try and move the aviation and the drone workforce and industry forward in the Monterey Bay area. I'm really excited to be joined by our panelists. Today we are going to have, we're going to be joined by Naira, and I apologize if I don't pronounce your last name quite correctly, Hovakamayan, who is joining us from the University of Illinois at Urbana-Champaign, Kofi Asante from Elroy Air, and Ricardo Sanfelice, who's also from UC Santa Cruz. So let everyone introduce themselves and have a few opening remarks, and then we have some questions to discuss. If we want to start with Naira.
Hello, thank you for inviting me to join this exciting panel. I'm Professor of Mechanical Science and Engineering at University of Illinois, Urbana-Champaign, and my work focuses primarily on autonomous systems, machine learning, control technology with broad applications across different industries, with aerospace being the most prominent among all these. So we have a track record of flying a subscale Boeing 757 for NASA's AirStar program during 2007-10. Later, we flew the same controller known as L1 adaptive controller on Learjet and F-16 at Edwards Air Force Base, where we have proven unprecedented robustness properties of our controllers for challenging scenarios, including holding the aircraft in stall and post-stall without losing stability. This work has opened unprecedented opportunities for us to collaborate across different industries, including Statoil, Schlumberger, Caterpillar, and many others. Basically, our controller has been commercialized for Marine Evolution autopilots for hydraulic pumps at Caterpillar, including all these different drone companies and so on. Having said that, I'm also co-founder and chief scientist of IntelliNair, a company that provides insights for farmers for sustainable agricultural practices. We started it as a drone company, but very quickly in Midwest, it proved that drones cannot scale for large volume crops. And we switched to Cessna airplanes for data collection, and we developed advanced machine learning algorithms for data analytics to help farmers to get better insight into their crops and the health of those ahead of time for smarter decision making. Having said all of that, I want also to talk a little bit about the recent Center of Sustainable Aviation that we launched at University of Illinois through internal funding, and I'm a lead PI of a NASA University Leadership Initiative that addresses certification challenges for autonomous systems. And at the same time, our director of this Center for Sustainable Aviation is a lead for electric aircraft, also another ULI, University Leadership Initiative from NASA. With that, I think I gave already enough background on our work. I'm happy just to let others talk. Thank you very much.
Thanks. Kofi?
Awesome. Good to see everybody. Kofi Asante, VP of Business Development and Strategy at Elroy Air. At Elroy, we're building an autonomous cargo aircraft. So not moving people, but entirely focused on cargo. And it's VTOL. So this means that you don't necessarily need airports or vertical takeoff and landing. It's a hybrid electric. And, our core mission is to democratize access of express logistics. We fundamentally believe that by doing this, you can help improve quality of life all over the world. Our aircraft will be able to carry up to 500 pounds over 300 miles, about 150 miles per hour in cruise flight. We've been at this for the last 6 years, raised about $100 million. And, we have FedEx as one of our core commercial partners. On the military side as a dual use system. We have the Air Force as our core anchor customer there. And then the humanitarian side is the World Food Program. The World Bank mentions pretty often to us that over 1 billion people are disconnected from reliable roadways. And so we want to build a new modality that connects a lot of those vulnerable communities without necessarily having to reimagine what that infrastructure is going to look like. I've been here for about 4.5 years, helping build up this company. Before my time here, I was over at Uber under the Advanced Technology Group. We were focused on autonomous trucks. At the time, the founder of Uber asked us to build out a new division called Uber Freight. And so we created the trucking portion of Uber at that moment. While I was there, I also had an opportunity to build a company within Uber Freight called PowerLoop. And I named it PowerLoop because you have your power unit, and then you have essentially your trailer. A lot of times truckers are, waiting for hours to get loaded and unloaded. And so we load trailers ahead of time. You'd have the power unit come over, connect to that trailer, and then loop to your next load. Hence PowerLoop. That's now the bridge for autonomous trucks and Uber Freight. And, that's been going on for the last 5 or 6 years. We're essentially going to do something very similar to that in the sky with Elroy Air. I actually have 2 videos that give you a little bit of an overview. So whenever you want to show those, happy to have those play.
Yeah, it would be great to just get a quick overview now, and then hopefully Ricardo will join us and he can introduce himself.
Awesome. I think Janice might have them. Perfect.
When you look at the Chaparral aircraft and you're standing in front of it, it's easy to think that all the development of the aircraft lays within the confines of the physical aircraft itself. But in fact, there have been years of testing, of analysis, of design, of experimentation that have led to all of the things that go into the aircraft to mitigate the risk to the maximum extent that we can.
Elroy Air is a team of brilliant, kind, dedicated experts in aerospace, logistics, and robotics, all working together to improve the speed and the reach of express shipping.
We know that logistics is the lifeblood of civilization, and if we're able to be any part of that solution and being able to bridge that gap, I think that we'll be able to make the world a little bit better. Awesome. And the next video is really our vision for how the concept of operations is going to work. And so if you notice, this is a typical warehouse where you have ground transportation. We're trying to enable air cargo in places that fundamentally haven't been there before. So you have the cargo pod deposited, pick up another one that's already loaded, similar to drop freight and trucking. Takes off vertically, hybrid electric. You're skipping over a lot of this infrastructure, roadways, airports, water. You're going point to point, looking at it in the commercial, military, and humanitarian market, all of them being very important to us. Being able to utilize existing infrastructure like helipads, you notice it there as well. Yeah. Awesome, thanks.
Thanks, that's great. And I think Ricardo has now joined us. So Ricardo, if you'd like to introduce yourself and explain what you do at Santa Cruz, that would be great.
Very good. Thank you, Becca. So my name is Ricardo Sanfelice. I'm with the University of California, Santa Cruz. And I'm very excited to be here and provide some input on the topics of the project and of the panel and the things that we are doing. Let me just share my screen, give you a quick overview of what I lead. I lead the Cities Aviation Initiative, and here's our website of the CITRIS and the Banatao Institute website. Cities Aviation is an interdisciplinary development that brings cutting-edge research that focuses on applications related to aviation, but also emphasizes the need for aviation, the policies that are required, and how those will affect the social and economic benefits for everyone. Aviation is, as you know, is a very important component of our infrastructure, not only our country, but the entire world. It allows us to connect everyone. And as we know, the pandemic has had a big impact on aviation. And CITRIS has this initiative that I lead, which is extremely well positioned to connect UC Berkeley, UC Davis, UC Merced, and UC Santa Cruz, and several partners in the area interested in CITRIS aviation. On my spare time, I'm also a professor in electrical computer engineering. As I said, I work on control systems and automation. I focus on the design of algorithms for complex systems, in particular systems that require multiple controllers. You can relate this to aviation in the context of avionics systems, where you have an algorithm that will be very good at controlling the system, the aircraft in level flight, but then there will be another algorithm that will be very good at landing or takeoff or avoidance. And the supervisory techniques that are onboard avionics that allow to control and select the right control algorithms are the things that I design on my research. So with that, I will go back to you and stop sharing. Thank you, Becca.
Great, thanks. So we have a bunch of really interesting questions to discuss. So I figured we'd just dive right in. And the first one goes to Naira. Of all the current smart infrastructure developments in process in the aviation industry, what do you see as the most exciting arriving in the next 2 to 5 years? And what's the role of smart tech in promoting greater resilience and sustainability in aviation?
Thank you. Very interesting question indeed. I think the most exciting developments I see in the area of urban air mobility, which we call today advanced air mobility. Otherwise, there is a broader term already for that. And I mean, our NASA University Leadership Initiative was focused around that. So bringing flying cars to reality, that once we thought that the movies like Fifth Element, Jetsons that we're grown up with, seemed like fantasy. Today it's getting closer to become a reality. And I think making it all these developments very affordable. So if in the beginning, for example, a flying car can be just a rich man's toy, hopefully down the years it would become affordable and accessible to everyone. And this is a natural evolution of all kinds of maybe transportation and mobility solutions. When Tesla first appeared, it was over 100K. Today we have affordable Teslas for everyone almost. So I think addressing some of these autonomy challenges, control problems, machine learning that come, and making sure that one can run all this in a reliable way with all the safety guarantees, with provable safety guarantees, and enable certification of these on the most rigorous footing is kind of the current big challenge that we all have to overcome. This comes with regulatory environment challenges. Obviously, we need to have the appropriate regulatory environment to enable these developments in a smooth and comfortable way for everyone. And obviously, these developments need to involve all the diverse layers of our population, all the students from K-12 to very senior levels, so that the workforce will be prepared for that. You know, I always say, like, my company experience taught me to a very good lesson. When we first started and moved into agriculture, the farmers were telling, just give me the insights, don't give me the decisions. Let me take the decision on my farm. Just bring me the picture and say, where is the problem? I'll take my decision. But today, as those farmers started driving maybe Tesla models and so on, they're happy also to get the decisions into their hands, not just the insights, right? So as the society evolves, different industries have impact on each other. This is also very important to understand. As you become a user of very advanced technologies in one area of your life, you start kind of scaling those same solutions and the same vision to other areas of your life. So I think that it's very important to keep this holistic vision of all the developments in the world to make sure that we can maximize and leverage the advances from one industry into another and have shortcuts in certain development time. I think that's why focusing on very good, healthy education, teaching students about the big vision, big picture, and how they can transfer skills and learned lessons from one industry into another, from one classroom into another, is critically important. Did I answer the questions or not?
Yeah, no, I think that was great. It's really interesting to see how all the different pieces play together and sort of can support one another as the industry develops and moves forward. So I guess the sort of leading into the next question is for Ricardo. What are the most pressing challenges we face in adopting new aviation technologies? And sort of that could be anything, but sort of looking at drone delivery or electric passenger flights, those kind of changes that we're starting to see.
Thank you, Becca. How much time do I have? Maybe a couple hours?
Yeah, right. Settle in.
Yeah, I was looking at this question the other day and coming up with a laundry list of things. There are, certainly a lot of things. So first, we want this new technology, maybe drones, maybe quadrotor type, maybe vertical takeoff and landing type, mostly fully electric, right? Maybe passenger, maybe loads, maybe packages. So we want these systems to be very, very much available to us for personal transportation, but also for transportation of goods, and also for bringing goods to, people stranded, all sort of rescue missions, and also monitoring wildfire. So there is a lot of technology there that, a lot of application that this technology has possibilities, right? As I said before, there are many challenges, in my opinion. Again, 5 items. I will probably come up with 10 if you have more time, but 5 items just to start the discussion, and maybe others have other opinions as well. But regulations is one of them. Using drones is something that in most cases requires a regulation, right? In most countries, and many countries have different regulations. So the question is, you create a drone in one country, you want to use in a different country, you might not meet those regulations. So challenge there, how do we make sure that the regulations are somewhat homogeneous and that things can be developed universally? That's, I think, is a big important challenge. Otherwise, we will continue being slowed down by the important need for regulations, because that leads to safety, and that leads to what we need to do in order to have these systems deployed properly. The next one in my list, again, the order is not necessarily by priorities, but power and endurance. That's another very important one. The kind of batteries that these small drones might have, or have, as we know, are rather have more weight than we want them to have, and they get used up quickly. So we need to figure out ways to have this power provided to the drones and maximize endurance. Actually, just before this meeting, I was running another meeting for the Cities Aviation Workgroup, where we had a very exciting talk by a company in Switzerland, XI, not trying to advertise them in any way, but definitely a lot of progress in that direction. I see a lot of opportunities, but at the same time, then we need to figure out ways to augment that. Maybe switching type of energy, maybe looking at different type of batteries. We know that hydrogen fuel cells have a lot of opportunity there. Again, that's one potential option. There's a lot of research going on there, but power endurance, and that leads essentially to how much time can you have these systems being operated without much human intervention. Which brings to the other point that I have in my list, which is safety, security, and privacy, right? So when you look at drone technology and regulations for drone technology, they require B+ requirements, right? You need to fly with a visual line of sight, right? So the question is, how can you move away from that when you want to actually go far places if your power system allows you to do that? So there's a very important question there about safety, right? When now you have essential remote control or totally autonomous aerial mechanical mass flying around, right? And then how do you control that properly? And how do you guarantee that it doesn't hit any sort of human or infrastructure, and it doesn't create any harm, right? So that's critical. Again, it's all interconnected, power, regulations interconnected. And then it brings back the question of security, right? We're looking at systems that can create harm in addition to provide services, but security is important, it's critical, because now you may have agents that are not benign, and they try to essentially make that system do something that you don't want them to do, or that it wasn't designed for, right? And then there is a question of privacy as well on top of that, because you have these vehicles navigating and maybe taking images, and those images need to be, have some sort of privacy attachment to that, which again brings back to the question of regulation. I have two more, but I'm going to be brief on those. Another one is navigation. That's very important. We're very used to having access to GPS, but these systems might not be flying where GPS is available. So can you create new technologies, maybe based on satellite systems? And there are many of those being created, like SATCOM for UAVs, but are there those very reliable that you can fly these systems in a manner that is robust and maybe with GPS denied capabilities, right? Which is critical for anything that to some extent tries to automate a system moving in 3D space, right? And last but not least, as I said, communications, right? Communications is critical, and there are certainly good areas where we have communication and very important areas where we typically need to attend, like areas where there is a wildfire, and there is now probably communication capabilities. So how can you actually control these systems, monitor them, make sure their power, and make sure that privacy and safety regulations are met? So again, not try to overwhelm anybody, but there is certainly a large number of challenges. Many of them, maybe some of you and some people in the audience have already resolved. But the question is, can we actually make progress on all of them in a holistic manner?
Yeah, it's definitely a lot to think about, and I think I would pass it to Kofi, because I suspect your company has thought a lot about a lot of these issues already.
Yeah, absolutely. I think the regulatory one that Ricardo was hitting on is the one that a lot of the smaller UAS, so the unmanned aviation systems, right there, they've done a lot of good work in that space. I think about some companies like Zipline and Matternet if you go to Rwanda, there's more unmanned aviation than there is even manned aviation. They're literally dropping blood from the sky. It's a really beautiful story of emerging markets being able to adopt this type of technology relatively quickly. But in order to do that, I think, you needed to have a strong product market fit, an inelastic type of need, one, even centered around healthcare, and a willingness from the government all the way up to, for them up to President Kagame in order to be able to really accelerate that. But they've done hundreds of thousands of flights over there now. I think that a lot of, what's happening here, especially with the FAA, is a little bit more of a kind of tapered approach to it. So there's waivers that are being given out right now. If you look at Matternet, they just had an opportunity to be able to go from, one pilot managing, a fleet of 20 of their drones. I think moments like those are really exciting, but then still end up being kind of limited in scope operationally. So regulatory is a big one. The next piece after that is then going to be the bigger systems like ours. We fit more. We're about a 2,000-pound aircraft. And so we look more like a flying taxi. I know that Naira was talking about the Jetsons. Our name actually comes from there. So the boy in the Jetsons, his name's Elroy, and that's where it comes from. And, we look a little bit more like a flying taxi, only entirely focused on cargo. And so the FAA, and we were just in DC about a month ago, but basically Congress has said that, anything over 1,000 pounds is likely going to have to go through a certain process that's very similar to other typical, general aviation aircraft. And so you think of the Cessnas, the other kind of smaller aircraft, the rotorcraft, even helicopters, they have to go through a type certificate process. And that's something that, we're going to have to do as well on top of some of the operating licenses there. And detect and avoid, autonomy, airspace integration, like we're hearing those every day, all day. It's not just a, specific company problem or, opportunity to really reimagine regulation. It's something that everybody at that type of scale, both on the passenger and the cargo VTOL, are going to have to think about. But even before you get to those states, like you get to that type of problem, I think that's, in my opinion, that's by the time you've gotten there, you've solved a lot of pretty big opportunities. That means you've probably thought about production in a way where you can have these be, have more than a handful of aircraft out there. By that time, you have enough capital, your team is, grown to a really healthy state. So me and the rest of my kind of executive team, we spent a lot of our time raising money. And, I mentioned a little bit earlier, right? Like raised about $100 million. And that's just to get to a state where now we're going to be able to do more of our flight testing, right? So you're still in the R&D stage, but you have to raise $100 million for a tech company. That's a very different model than what Silicon Valley is used to seeing with software companies, where $100 million, you've already, scaled the product. It's in the hands of a lot of customers. You may only need to raise a little bit more before you even are in a position to IPO or have an exit. And so I think the capital one is the one that's at least like more near term. How do you continue to have access to capital, especially with how crazy the tech markets have been? That's the one that I think we spend a lot of our time. The last piece I'll mention, and I mean, this is kind of a call out to everybody here who's listening in. I think there's also been a little bit of a talent shortage in a couple of different environments, right? Like for us, it took us a while to be able to find someone who could help work on our powertrain. And, you think about that as like the core of our aircraft. That's the way that the aircraft is actually able to, move forward or, really get any of its power. And you're seeing this not just in aerospace, but you're seeing this with electric vehicles. You're seeing this with autonomous cars as well, where there's just a shortage of that type of talent. And so if anyone's just kind of subtle plug, anyone's ever interested in, learning more about some of the gaps out there, I think it'd be a good one for anybody that's trying to invest and figure out what areas that they want to dive deeper into. And maybe the last piece I mentioned is, have this thesis. I think me and the rest of my leadership team, we have this thesis that, the last 5 or 6 decades of aerospace have stayed relatively similar. In the last 5-10 years, you've seen more like innovation. You can see this with sustainable aviation, hydrogen was mentioned, batteries, VTOL, all these other really exciting opportunities that are popping up right now. Like the time it is now for a lot of that change. We fundamentally believe that the aerospace is going to look different in the next decade. it might as well be built by people who also look different. And so thinking about diversity, equity, inclusion, creating a space where people with different backgrounds and minds can come over and build the future and make sure that it is going to look different than the way that it has in the last couple of years is really important. And I think we've done a pretty good job of that at Elroy, but trying to get the rest of the industry to also go in that direction too.
Yeah, absolutely. I hear what you're saying. We work with different aviation companies and industries, and some of them are doing a really good job of trying to hire that diverse workforce and have those different perspectives. But yeah, I sort of turn and I look at the students who we're teaching, and it's not quite the same yet. Like we still need to improve on that. Some of the other criticisms that I've heard over the last couple of years about these new aviation technologies, or concerns at least, is their potential to widen that social and economic disparity as well, not just in the workforce, but in their application. Higher, like the airport shuttles, delivery service, and that kind of thing. Is there a way that you could see that we could work to make that equity gap smaller and allow everyone to use these services when they become available?
Yeah. And I guess as a question for us, it's like the reason we actually decided to focus a little bit more on cargo as opposed to passenger is, I think on the passenger side with the flying taxis and flying cars, like that reality, to Nara's point, right? Like that's now, that's happening. They exist. It's just about getting it out there in the space and getting it regulated, to Ricardo's point, right? Like they're there. We've seen them, and it's not a technological and feasible possibility anymore. But still, even if we think about the next decade, in order to make those accessible in a way that actually is going to service more than people who can just afford them, it's going to take a lot. And so we think about a pretty practical or pragmatic opportunity to actually democratize access to express logistics. A lot of people in fairly developed cities and countries are used to next day shipping or 2-day shipping, or even sometimes same day shipping. But when you go to a lot of other regions, that's just not a possibility. You may have to wait a week or so to get pretty critical goods, or there might be, weather that means that there's a trade-off between being able to have that type of logistics, even get to that community. And so now you're really in a tough spot. And so our whole thesis is actually we want to make it more equitable by creating this new modality that is decoupled from infrastructure, getting those costs down, making it pragmatic in the way of something you can do in real time, and actually be able to help a lot of those communities.
That's really cool. Naira, does your company and your work, how does that sort of focus and help you think about making that equity gap smaller?
I strongly believe that by making these technologies affordable, we can really make that equity gap smaller, right? So the cost is driving a lot in our life, and we have to understand that as the upfront investment into development of these technologies is just huge. Aerospace is always one of the most expensive industries, maybe comparable to healthcare, maybe. That takes lots of investment to come up with reliable products. And that's why its first products are typically very expensive. But down the road, we have to be able to democratize both the development of the science and algorithms that goes into these autopilots, into these advanced materials, hydrogen fuels, and so on. As we make all these technologies cheaper, that together they come and define the reliable vehicle. And the regulatory environment becomes more amenable for accommodating these technologies into our national airspace. Slowly the price will drop. And as it drops, it will provide a good environment to improve the diversity inclusion on a more aggressive scale. Because without diversity, there is no development. I'm strongly convinced in it. The diversity and inclusion lie at the heart of all the development. And unfortunately, aerospace industry is the industry that has been mostly man-dominated. It's either due to citizenship requirement or due to its strong connection with military, where we have mostly men serving, and so on. So bringing diversity to the aerospace industry has been maybe one of the most challenging dimensions of our work, because I attend different conferences like organized by IEEE or AIAA, or ASME and so on. And the AIAA conferences were always the most men-dominated, hard to find women and so on. I think we need to expand it. We need to prioritize it, because problems get solved usually when you prioritize them in a very well-defined way, backed up with appropriate resources, appropriate capital to go out and recruit these people to come and work for these new emerging industries in hydrogen fuels, in materials, in autonomy, and starting it from K-12, from universities. I think we can play a significant role here.
That's really great. Yeah, I mean, we see this all the time of like, how do we pull people into these so that they can then feed into the workforce? Are there any particular techniques or ways that you've seen to bring students into these specialities and then feed them through into the industry that have worked really well so far?
Well, it's a priority dimension for our NASA University Leadership Initiative effort that we established this Center Aviate, and working with diverse groups, organizing, for example, summer workshops for high school kids, reaching out to science museums, and establishing cross-collaboration across different universities and industries that are part of this consortium. And we have Lockheed Martin with us, we have Sierra Nevada Corporation with us, bringing everyone in and defining a well-defined project scope for them to work on that would excite them. It's critically important. We also leverage the resources of universities in terms of diversity recruitment and in terms of getting the best outreach and getting it at early stages. You know, as I said, aerospace industry seems to be the most man-dominated, but it's also the industry that's very easy to excite people into it, because flight always excites everyone. Trust me, I have gone to kindergartens, to the workshops on robotics with 3 to 5 year old kids, and they get so excited when they see something flying around, and they can connect themselves with these flying technologies. So prioritizing these engagements is critically important. It won't happen on its own if we don't make it a priority. And certainly recruiting these minority students, women, and so on, and making sure they feel equally well treated in our labs. They work side by side with their men colleagues, and providing this fair, inclusive environment for their work is critically important.
Yeah, absolutely. And I think it's starting to make a difference. But, Kofi, have you started to see a shift in the industry yet, or has it not really gotten to that point yet?
I think there's still an opportunity for growth. Part of the exercise is from two different angles. And so one of them is, even just being aware at an early enough age that this could be an opportunity. Like you could spend your time doing something you really enjoy, you get really excited about, and which specific roles do you need to be focused on when you're an undergrad or you're in high school or whatever it ends up being to get there. So I think that's one side, and trying to make sure that everybody understands that this world is for them, right? Like it's not going to be, it shouldn't be homogenous. It should be for everyone who wants to have access to coming here. And then the second one is on, teams like us and the rest of me and my leadership team, right? Like I think these companies that are growing right now, when I joined, we were less than like 10 people. That we've like almost 10x that in the last few years. Like there's going to be opportunities for new roles that pop up there, and making sure that the teams are aware and care about not only creating an environment that is inclusive, but then also, putting themselves in the right spots to be able to find that solid talent. And, with our team, been really proud, a good amount of the people within different leadership buckets. So whether it's like chief engineer or head of industrial design or supply chain are women and underrepresented minorities. And so we've, put that first as something that we're prioritizing. But I think it's got to come from the leadership teams at these growing companies, because that's where a lot of the new roles are likely gonna come from. Yeah.
That makes a lot of sense. Yeah, I think one of the things that we focus on and try and do is sort of building that bridge between what companies are looking looking for in their workforce, and then communicating that back to the university and seeing if we can structure courses or training programs to actually give the students the skills that the industry is looking for. And so I would ask Ricardo, what kind of, how best do we prepare from the university side to sort of meet that demand in terms of the new technologies in the workforce?
That's a great question, Becca. There are many, in my opinion, many ways to, contribute to reduce the shortfall on workforce. I was looking back in the beginning of the pandemic, some statistics, and I looked again the other day, and we were looking at, based on some numbers, about $30,000, 30,000 people, 30,000 pilots needed more than predicted by 2026. According to some numbers, that number now, that prediction is close to 26,000 for pilots needed by 2026, more than what we expect to have available by then. The reason that this became an issue is because many pilots, according to the data, had early retirements at the beginning of the pandemic, when things are starting to be grounded. So there is, a reduction on the prediction of pilots needed by 2026. That's a good sign. And one reason that people have been mentioning that this is a reason that the decline is not that severe is because many airlines have reduced their service. So now there are not that many connections for all hubs that we had before, which creates another issue of, inconvenience for transportation. So at the same time, there is a lot of shortage predicted on engineers, aircraft engineer, mechanic engineering in particular. That's going to be something that we need to put a lot of emphasis on. And when your question comes to me, to academics environment, the one thing that I always see in aerospace and mechanical engineering departments is that typically the mechanical component of the department is much stronger than the aerospace component. I was at the aerospace and mechanical engineering department at the University of Arizona for several years, and we have pretty much a 2 times number of students in mechanical versus aerospace. I think this is somewhat something that it was going to help, the creation of new engineers, but something needs to change. Why? Because now we are looking at more complex systems that are not fully mechanical. We are looking at more electromechanical systems. So we need engineers that not only understand the mechanics, but also understand the electronics and understand the computing part as well. So in my opinion, my humble opinion, we need to look at more degrees that are more intertwined, that are not pure mechanics, pure aerospace, but that are more combining electrical and computer, and allowing this workforce to be trained in these more complex systems that are not just the traditional systems. So having said that, at UC Santa Cruz, we have a robotics engineering degree, and there are a few of those in the country. There are not that many, and we focus on teaching students not only mechanics, but also electronics, and that somehow materializes into robotics to some extent and control. So what we can do is to continue diversifying and making these frontiers of departments less significant, and be able to train and allow these students to take more courses outside of the domain, and be able to create, an expertise that will allow to create engineers that we need for aircraft systems of the future. Now, how that degree is going to pan out, I don't know exactly. I know that many universities are working on this, and I look forward, to seeing the future programs being established on those topics. But that's my opinion about where we're going, what we need, and maybe a way that we could get there by diversifying our programs, maybe making some adjustments on drone research, drone education early on in the careers.
Yeah, that's really important. We've definitely seen that drones are just, people get so enthusiastic about them that they're a really easy way to bring people who may not have otherwise been in the aviation space in education in there and get really excited about it. So we have about 5 minutes left. So if anyone who's listening has any questions they would like to pose the panel, please put them in the Q&A. And while we're waiting to see if any questions pop up, does any of the panelists have sort of closing thoughts or things that we haven't touched on that you'd really like to talk about?
Yeah, happy to take any questions.
Great. Well, we have one from Michael, which is, what do you see as the pathway forward managing sort of the dimension of air traffic in the future? Sort of thinking about, the FAA manages for plane flights and deliveries, but we don't really have a way at the moment of managing that middle step with the urban air mobility and package transport and drones themselves. So probably Kofi, if you want to start.
Yeah, I guess I'll give a quick response since I know we're short on time. It's something that a lot of the industry is trying to figure out, whether you think about it as radars or cameras and how they're able to see the world. Those are some of the pieces that are working in parallel. So outside of OEMs like us, we'll actually just integrate radars and cameras from other groups who are entirely focused on how they see the world up there. And then, we'll still have a pilot in the loop so that pilot can interact with air traffic control and work on deconfliction and take control of the aircraft whenever they need to. But for the most part, we want to make sure the aircraft can make the decisions up there.
Yeah, absolutely. Naira, with your experience, so you have ideas on how we can help manage the air traffic?
Air traffic, I think it's the level of autonomy that we have to improve so that the aircraft will be capable of taking its own decisions, lots of it done autonomously, right? We always have this Captain Sullenberger example of landing in the middle of Hudson, how his brain, with 42 years of experience, trained well, guided him that Hudson would be the best location to land and saved 155 passengers. So we're trying to achieve those levels of autonomy with our solutions, methods, PhD dissertations, and so on. That's the big goal to have.
Yeah, no, it absolutely is. Yeah, we'll have to see how we get there. We did have a question about the details of the aircraft, Kofi, in terms of what height does the aircraft that you work on operate at, and
Yes.
Yeah, is this based on external regulation or internal decision to avoid colliding with others and your own aircraft?
Yeah, absolutely. So we can go up to 20,000 feet. That's the technical kind of limits of where aircraft would go. The regulatory environment hasn't been standardized across the board of exactly where you need to go, but the FAA's immediate feedback is likely going to be in the 5,000 to 10,000 feet range. So we won't even need, all that 20,000 feet. In other countries, because we're going to, focus on international as well. As we get that feedback, we'll be able to figure it out. If you zoom out a little bit, it's kind of like it's a much easier exercise to think about how do you deconflict when you're up in the air than necessarily on the ground. For my time over at Uber, when we were thinking about trucks and cars, because you can alter those altitudes to make sure that you're not really in the same environment. And so that's really helpful.
Great, thank you. Another question that's come through is thinking about the autonomous flights and how those are managed, and comparing it with autonomous cars and self-driving, like all the problems that we're seeing with Tesla and other companies having that autonomous driving. Like, does that translate into problems we may have with autonomous flight, and how do you manage that and sort of account for problems that may occur?
If I could say here a few words, I strongly believe, I don't know why, that completely autonomous flight will happen sooner than maybe complete autonomous driving, because in the air we have lots of the challenges, like unpredictable pedestrians don't appear in the air. And there are lots of other similar things that we face with self-driving cars as challenges on the ground, where humans are in much closer proximity outside the vehicle itself, while in the air, so it's only the humans on the vehicle. However, the regulatory environment, the certification challenges, stability challenges, and so on, if you have a very robust, reliable controller and a well-run optimization algorithm that can manage your air traffic and integrate, and you can do pre-planning given your weather, you should be able to achieve higher level of fidelity and kind of reliability with flying vehicles. While with self-driving cars on the ground, there are always humans around. It's very hard to predict. And humans are non-scalable. Just let's start from there. So in some sense, I'm more optimistic about the autonomous flight being sooner achievable than the fully autonomous driving.
That's great. Thank you. And I think we're getting close to time. So I guess the final question is, do you guys have any what would your advice be to students or people who are interested in changing sectors or getting involved in the aviation space?
Students who are studying, I would tell them that the bar for high quality work today, it's much, much higher. They have to be very serious about the courses they take, from math and physics to programming to testing, validation, because having reliable flight, it's about millions of hours testing, right? So students need to have this bigger vision that captures everything from theory to testing, validation, working today with a smaller vision, without the big holistic picture, with a smaller skill set, without understanding the need of other skills, is going to hurt them. Today, the multidisciplinary, interdisciplinary education is at the hallmark of achieving all these properties and the quality of life that we want to have. We want to see it in our lifetime.
Yeah, and I guess I have a few thoughts. The first one is, this is a really fun space to be in. So whoever wants to come join it, if your heart's in the right spot, I think there's a lot of ways to get involved. You don't need to just purely be an engineer. I'm not an engineer. Came from liberal arts background and now kind of running our business development and corporate strategy team. But I think this idea of being able to connect the dots when they don't necessarily seem clear. So critical thinking is really, really vital. Another piece is to just talk to people in the space. And so don't be afraid to ask or reach out, so you can get a sense of exactly where you want to fit in here. And then I have some unconventional wisdom. This is just my personal opinion, but I wouldn't probably take this to heart, but I think that it's more important to think about initiatives while you're an undergrad that show entrepreneurship, show that critical thinking, show innovation, than necessarily just purely optimizing for GPA. At the end of the day, when you come out of undergrad, you're all of a sudden going to be in a position where, based on the way you built your network or the specific focus you wanted to be in, your GPA is no longer going to be mentioned after like your first opportunity. And so there's a lot of focus on that, and it makes people nervous to take risk and try new things. But I just say, try and do things that are challenging, so you can tell that story of a project that you actually accomplished. I think that's going to actually help you more proportionately. Yeah.
Oh, that's great.
Last plug is that this space is for everybody. I keep saying that over and over again, but no matter what your background is, what you look like, there's a way to be a part of it. Yeah.
Well, I guess, and then for Ricardo, if you have a very small advice that you want to give people.
Yeah, I just wanted to add one more dimension. I agree with what Nera and Kofi mentioned, but aviation is such a diverse and multidisciplinary area, and people can get involved from many aspects. Manned systems is one of them, but there's also air traffic management, aerospace engineering, aeronautics, aerospace psychology, aviation maintenance, business administration in aviation. So there are a lot of aspects of this very important infrastructure that people can contribute in many aspects, and I think it's a very exciting. And I agree with Nera. Is also very, very tough, right? Because it's a well established, and people might get somewhat very excited about the opportunity, but at the same time there are a lot of regulations, right? So one needs to be to some extent aware of what's available, what's possible. And starting from a research opportunity, I say is very exciting, because then you can do pretty much, implement things, you can make changes, and then try to accommodate to what is needed in the real world.
That's great. Thank you, everybody. This was a really great discussion, and I loved hearing all the different perspectives of where you guys come from and the experiences that you've had in the industry. And I think I will hand it back to Camille.
Thank you, Becca. Thank you for such a great job moderating the panel. Thank you to our panelists who provided such great insight and career advice. I really appreciate all of that. And a shout out once more to Michael Matkin and to Ricardo at UC Santa Cruz for helping to organize the panel. That's the heavy lifting that's sort of behind the scenes that people don't see, but their work resulted in this really stimulating discussion. So thank you.